Okay, so today we are going to talk about something called scale drawings. Scale drawings. So there are four vocab words. So here we go. The first one is called a scale. Everyone? Scale. So here's what the book says it is. It says the scale that gives the ratio that compares the measurements of a drawing or model to the measurements of the real object. All right. Now, this probably won't make much sense right now, but it will in just a bit. So 1 inch is equal to 24 miles. Okay. So that would be an example of a scale. So let's get into the two different types of things that you'll see with scales. And the first one is called a scale drawing. Everyone?
Scale drawing.
So this is a drawing that is used to represent objects that are too large or too small to be drawn actual size. Okay? So here's an example. You'll see scale drawings in a couple different places. See it on a map. Okay? A map is a scale drawing. Or even house plans. So if you ever go to model homes, if you've ever been to model homes and you go in that, usually the first room, they have all the different floor plans to the different houses. They'll have them up on the wall or in cases where you can look at the house plans. Okay, those are a couple different examples. Okay, some of us, we have this idea that a map is just some kind of freehand, like, oh, look at this beautiful map someone drew. That's actually not the case. A map is actually truly a shrunken version of real life land. It is. That's what maps are. It's exactly a shrunken version. They are what we would call proportional to the real thing. Okay? So, let me give a nice example. True story, a little story time. The other day, I had to have some alterations done on a pair of pants of mine. I went to my dry cleaners, who I don't have to get alterations very often, but every once in a while I do. I took them there to get them altered. And right then, the seamstress that they usually have that does the alterations, I think, retired, or I don't know, the person wasn't there. All right, the guy or girl wasn't there. So they told me we'd have to send them away, but probably gone a couple of weeks. I said, no. So what I did was I went back in my car, I got on my phone, and I got on the internet, and I Googled, all right, I got Google up, and I Googled dry cleaners. Hit search, and of course by now, right, you guys know when you Google something, you have all of your search results that pop up, right? And most of the time the headings are in blue and you get to click on them and see what it has about them. It takes you probably to the website or whatever else. But when you Google an actual location, when all the results come up, right at the very top, there's usually a map. How many of you guys know what I'm talking about? Okay, you Google some kind of location, right? You put Toys R Us in there and there'll be a map. And you have little things that kind of look like this, right? All, like little bitty ones, like all over. They're kind of like a little arrow that's pointing to show a location. Okay? So, what I did is I turned around and I took a look. And if you ever take a look, sometimes, well, if you want to get a better look at it, I should say, you touch the map, right? And it will shoot you over to Google Maps, and your whole phone or your pad or your computer, whatever it is, will go to Google Maps, and you'll just see the map. And you'll get to kind of alter the map certain ways if you'd like to get what you want. Now, here's what happened, okay? So after I did that, it showed me. But the problem is that the streets were little lines, and I didn't know which street was which because it was like so zoomed out. It was far away, okay? The scale could have been something like 1 inch was equal to 24 miles. Meaning that on that phone, that length right there, 1 inch, in real life, if I was to drive that far, it would have been 24 miles. Now that's kind of like, being way, way up in the sky looking down at the little roads, right? I mean, you don't see really much detail. So what do? I take my fingers, zoom in, right? I expand it out, zoom in, and it kind of reconfigures depending on how fast your phone is, right, or how good the internet service is, and it kind of reconfigures, and then all of a sudden, if you've ever done that, those little lines all of a sudden have street names, right? And so now you can actually see specifically where most of these little things are, or the locations, point out the locations, right? What I did when I zoomed in, and I did zoom in, what I did is I just changed the scale. So what used to be like 1 inch being 24 miles, maybe now 1 inch is 3 miles. And you got to see more detail. Okay? So that's what a scale actually is. And there's scale drawings, like I've just talked about with a map. Okay? But also, there's something called a scale model, everyone.
Scale model.
So here's what this is. It's exactly the same thing, but it's a model used to represent objects that are too small or too large to be drawn at actual size. Okay? So, right, you can't, for example, scale drawing, you have this huge piece of land. Well, you've got to shrink it down in a little drawing, right? That's the function of like Google Maps. Okay? A scale model, on the other hand, and by the way, a little example could be something like a model car that used to be popular way back in the day, but something that might be kind of similar to a model car is like a Hot Wheel. Those are kind of scaled down versions of real cars. Okay, well, some of them are, right? Others are like science fiction spaceships or something on wheels, but some of your basic Hot Wheels, right, are like normal cars. Bless you. So, another thing, and some of my students have seen these, some haven't. It all kind of depends on which science class you've had so far, but I always use this as an example, especially as you get into 8th grade and beyond into high school. You'll go into science classes, and sometimes, depending on the science class, you'll be studying certain things. Well, an example would be something like, and it doesn't have to be exactly this, but an example would be something like your teacher may have this thing that you can actually touch, this 3-dimensional thing over on the side. It kind of looks like a trophy, but it might be in the shape of something like this, right? And it's sitting over on the side, and you go over there, and it has texture to it, everything else. And what it is it could be something like an enlarged, what it looks like an enlarged, blown up version of a red blood cell. Okay? So you can actually see the parts of a blood cell. Now, think about it, right? In real life, if you were to accidentally get a cut and you start bleeding, you go, oh no, look at all those little blood cells in there, right? You can't do that. You need a microscope, right? A high-powered microscope to look at the blood cells. Well, here's what I'm getting at. A scale model isn't a drawing. It's a 3-dimensional object that represents sometimes something too big, but also sometimes something too small, like a red blood cell. Okay, so with a model, you can look at all the different parts of a red blood cell. That's just an example. Science classes has a lot of those models. They could have like this plastic human heart where you could like take it apart like a puzzle and look at the different parts. Okay, when you get in go in the medical field, you'll see stuff like that and get to understand all those things. So that's an example of a scale model. Okay, so a couple of different examples. Now there is one other thing that I want to talk about, and that is something called scale factor. Everyone?
Scale factor.
All right, a scale factor. Here's what a scale factor is. It's a scale, but it's a special scale. It's written as a ratio without units in simplest form. I can actually pretty much say like simplest form being unit, like a unit rate. Okay, so here's what this means. For example, this is just an example. Let's say you have a scale, 1 inch equals 2 feet. Okay, so that big, whatever you're talking about, that big is actually that big, okay? So what I'm going to do is convert this to have this, because they have to have the same units before we drop the units. So what that means is 1 inch to 2 feet. I would then just change the way 2 feet looks to make sure they're both in inches. Well, 1 inch to 24 inches. That is the same as that, okay? But because 2 feet is exactly the same as 24 inches, I just made it where they'd have the same units. And as soon as I have it like that, I can then drop the units and write it as a ratio. It's a 1 to 24 ratio. Ultimately, here's what a scale factor is good for. Okay, it's good for a lot of things, but one of the things is you can say, oh, if I have it as a scale factor, I can say whatever this one is, whatever the 24 represents, this is 24 times larger than that. And that is kind of what a scale factor is. Okay, when you're talking about a dimension, a length or a width of something, it would be 4 times larger. Okay, so here's what I want to do. Let's go ahead. And the first thing I want to do is you're going to need rulers for this lesson. Okay, so I think there's 8 of each, so make sure there's 8 of each in each art bin, guys. I'm going to just give you guys one 1 minute, okay? Go ahead and grab a ruler, or grab an art bin, I should say, and pass those out. 1 minute, go. All right, here we go. What I'd like to do is I want to start off with a problem that is not one that you're going to actually write down. I just want you to watch. I'm going to do a very simplified one, but I want to show you in general like how a scale works. Now, before we get started, I do want to explain this thing here. Okay, what's that called? Ruler. It is called a ruler. Okay, ladies and gentlemen, I do want to introduce you to what's called a ruler. It is not, let me clarify this, it is not a sword. It is not drumsticks. And it definitely is not a helicopter. Okay, we know what I'm talking about. We see students do it all the time. So please, these will break easily, and more importantly, because a lot of them are plastic, they're very sharp and they could do a little bit of damage on people. So please, let's use them. If you don't use them the right way, you're going to lose a privilege of using them in our class. I want to make sure everyone's safe. So make sure, guys, use them the right way, okay? I think this is the first time we've actually used a ruler in class all year, so I want to make sure that I went over that. All right, so here's what I want to do. Okay, let's go ahead and take a look. Let's take a look at page 578. Again, you don't have to write anything down, but I do want you to take the ruler and just set it down along with your pencil carefully. And let's take a look at 578. We're just going to do, I'm going to start off with a very basic problem. Okay? So, let's go ahead and close read this. Here we go. It says, on a map, everyone with me? We're on 578, the guided practice part. Okay, number one, let's try it again. On a map, the distance from Akron to
Cleveland
measures 2 centimeters. What is the
actual
distance if the scale of the map shows that 1 centimeter is
equal
to 30 kilometers? Okay. Now, just to kind of make this a little more real, first of all, guys, centimeters, right, are about that big. Okay, they're metric. They're not in inches. They're metric. Okay, inches are customary for the U.S., but it's metric like used in most of the rest of the world. Okay. The other thing is kilometers is also metric. If you want to know, and just to let you kind of get a rough idea, it's not exactly the same, but you can compare like a kilometer to a mile. They're not the same, but you can think of it like in terms of that. It's pretty far. Okay. So if I do this, okay, here's the very first thing I'm going to do. I'm going to take the scale they give us, and they tell us the scale to this map is 1 centimeter is equal to 30 kilometers. I'm going to go ahead and write that as a ratio in fraction form. What we're going to do is we're going to use our good old-fashioned friend that we learned earlier this year. We're going to use a proportion. So remember, with proportions, we set up 2 ratios. They're equivalent to each other. The units, same units, are side by side. So centimeters on top, kilometers on the bottom. So we set it up just like this. Now the next thing that we're going to do is they're going to tell us, of course, in this case they tell us, how far it is on the map from the city of Akron to the city of Cleveland. And it says it is 2 centimeters. That's the distance between the 2 cities on the map. I'm going to go ahead and put 2 centimeters up on the centimeters. Now what I'm going to do next is I can use cross products, and we'll talk about that in a bit. But if you don't have to, don't do it. This one's nice and easy. 1 times 2 is 2. So 30 times 2 is 60. Now, this is not your total answer. We use this whole proportion as a tool to find out our final answer, and that is the two cities are 60 kilometers apart. Okay, and that's the basics to what we're doing today. Okay. So before I let you ask any questions, let's actually go ahead and do a problem together. So what I want you to do on your book, let's take a look at page 579. 579. Let's see if I can fit this all in here. Okay. Now, really quickly, 579, let's take a look at number 1. The directions say, find the actual distance between each pair of locations in South Carolina. Use a ruler to measure. Now, really quickly, I do want to say that this is not a nice, pretty drawing that is made. This is a scaled down version of the actual state of South Carolina with the actual cities. Okay, this is a map. All right. Now, before we begin, let's go ahead and do step 1 since that's the easiest. We need to go ahead and put our scale down in ratio form. So our scale, if you don't know, is right down here. That's what a scale will look like on a map. Okay, if you go to Google Maps a lot of times, or sometimes anyway, you'll see something like that on there. So if I take a look at this scale right here, it is 27 miles is the same as 1 inch. So this distance on this map is 1 centimeter, but the distance here in real life, if you were to get in a car and drive, would be 27 miles. Okay, so I'm going to go ahead and write that down as a ratio. So 27 miles over 1 centimeter. Okay, doesn't matter which one you put on top and bottom, as long as you keep the same unit side by side. Okay, so now what we're going to do is we're going to do step 2, and that is we're going to set up, bless you, a proportion. I'm going to put a little asterisk, a little star by step 2, because you need to remember the same units side by side. So miles are on top, centimeters are on the bottom. Now remember on this nice one we did over here, they said, oh, the distance between them is 2 centimeters. Now there's an issue with this problem. It doesn't tell us the distance for number 1 between Columbia and Charleston. That is actually step 3. We need to find that out by measuring it with our ruler. Now, before you begin, and before you assume you know how to use a ruler, there's one thing I've noticed over the years of teaching 7th grade. A lot of students who assume they know how to properly use a ruler, unfortunately do not know how to use a ruler. Okay? So even if you know, hopefully all of you guys do, but even if you know, I want you to listen. Okay? Here's the first thing you need to know. Okay? On most rulers, not all, but on most rulers, you're going to have 2 different types of measurement. In this case, this ruler has millimeters and centimeters. So each number is a centimeter, each little line's a millimeter. But this is basically metric measurement, all in centimeters. However, on the other side, if you flip it around, it will tell you these are customary units. These are measured in inches. Okay? So you need to, first of all, and this is a mistake people make, you need to know which one you need to use. Well, the funny thing is the miles are customary, but the map itself is built in metric. We need to use centimeters, so make sure you are on the correct side. Okay? Now, here's the other thing you need to know. All rulers are slightly different. All right, I shouldn't say all, but they're all a little different. Okay? And in this case, when I look here, on this side here, I take a look, 3, 2, 1, you need to locate your 0. Some rulers have 0, like mine will have 0 a little bit in from the edge, and you'll see the line, and then the little other lines will stop, because that is representing 0. Other rulers, 0 is the very edge of the ruler. So you need to identify, of course, be careful, know which one yours is. 0 is very important because that's the starting point when you measure. You need to put 0, or the line that represents 0, right where you need it. So in this case, for number 1, we're measuring Columbia to Charleston. So here's Columbia, has a little star. It's been a while since I've taken geography, but I think that's a capital city. I'm going to put 0 right smack dab in the middle of the star. So 0 is that line right there. It's in the middle of the star. Now I'm going to measure to Charleston. So Charleston, there's Charleston there. I'm going to rotate my ruler. Now be careful. People usually rotate their ruler and go, oh yeah, it's 4. But look what just happened when I rotated it. This side came off. So you need to make sure that both 0 stays on your starting point, okay, and your ruler goes directly to that next one. Now, I want to also review this. As a 7th grader, here's all I'm asking you to know, and you should know this by now, is on a ruler you should be able to at least measure to fourths. Okay, I think you probably should be able to measure more than that, but at least to fourths. Okay, now I know this is metric, but instead of using millimeters, we're going to use quarters. Okay, that's what fourths are. So take a look. This long line is a 3. This long line is a 4. What's the second longest line here? What does that represent on here? Here's a 3. Here's a 4. What's the second longest line represent? That's a half. That's 3.5 according to this. Okay. Now halfway between 3 and 3.5 would be about what? 3 1/4. 3 1/4. What's halfway between 3.5 and 4? 3 3/4. We have a 3, a 3.5, and a 4. But splitting those in half, I'm expecting for your homework tonight to have 3, 3 1/4, 3 2/4, which would be 3.5, 3 3/4, and 3 4/4, which of course is 4. In this case, it's halfway between 3.5 and 4. That is 3 3/4. Okay? Or 3, if you want to, well, I know a lot of you guys love decimals. There's nothing on this problem that tells us to use decimals or fractions. So if you want to, you can use a decimal, 3.75. I'm going to put that in for step 3, 3.75. Okay? So after I have that in, step 4 is I need to, let's go ahead and solve this missing part here. So I have, getting from 1 to 3.75, I can just multiply by 3.75. And whatever I do to the bottom, I can do to the top. And now you can do that, well, you can do that out if you'd like, or you can go ahead and use a calculator. All right, so with that said, 27 times 3.75 equals, and here's what I get, 101.25. Now, the other thing I want to say is this, be very careful. You need to be very clear. They're asking how far is it between the two cities. Write it down as a clear-cut answer. It is 101 2/25 miles. Write it by itself. And there's our answer. Okay, any questions?
I'm still confused on how you went with the 0.75.
Well, what it really was is it was halfway between 3.5 and 4. That is 3 3/4. But I used my knowledge of fractions and decimal conversions, and I just put a decimal. Okay, if you want to put 3 3/4 and then multiply 27 with 3 3/4, you could do it that way too. I'm okay with either way tonight, as long as they don't have a fraction or a decimal in the problem. If they do, then you need to use that type of number. Okay, other questions? Okay. All right, so here's what I want you guys to try out. I want you to try out the very next problem, problem number 2. Okay, I'll check in with you guys. I'll give you guys 1 minute. I'll check in with you guys in 1 minute. Go. All right. How many of you need more time? Okay. All right. I'll give you guys about 30 seconds or so, and then I'm going to have you share. Okay, 30 seconds. Go ahead and turn to your neighbor and share. Go.
I also got 8.
Okay, here we go. So problem number 2. Let's take a look at some answers that you guys have out there. Mileage between Hollywood and Sumter. So we've got seat 16.
I didn't understand.
Okay, make sure you ask questions. All right, when we did the steps, I keep the steps up here for you. Make sure that time is for you to follow those steps. Okay, seat 15.
I did the problem number 2 on the 17.
This one here.
Is it on 578?
No.
I did say the very next problem, right? Okay, seat 17.
You want the answer?
Yep, please.
I got 81 meters.
All right. 81 meters. Agree, disagree. All right. Okay, a lot of, okay, anyone want to add something? Ashley? Oh, 81 miles. 81 miles. Agree, disagree now. Okay, oh yeah, there we go. All the time. Okay. All right, 81 miles. Yeah, meters, remember, is just M. Miles is MI. So, all right, let's check it out. See if you guys are right. So, Hollywood. Let's go ahead and grab my ruler here. We're talking same thing, right? So I go ahead. It is still the same scale because it's the same map. 27 miles over 1 centimeter equals miles over centimeters. So I go ahead and take a look at those two cities there and there. I put 0 on one of them, and I go across, and this is pretty nice because it's about 3 centimeters. So, this is nice and neat, right? 1 times 3 is 3. 27 times 3 ends up coming out to 81. So, 81 miles. All right, questions? Well, that's why I say just round like to the nearest quarter. Okay, that way it kind of makes it a little easier on you guys. Okay, yeah. So you're right though. That it's not the most accurate, but it's pretty accurate, at least according to what we're gonna do for homework tonight. Okay.
How did you get the 3? Because I got like right between 3 and 4.
Right between 3 and 4, you put your 0 on there, because it is maybe right between the 3 and the what would be 2.9, but it's almost 3.
I think we used
Okay, let's see me after class. We'll take a look. All right, here we go. Let's take a look really quickly on page 581. Okay, let's take a look at problem number 17. Number 17. Okay? Let me try to alter this. We can see it. All right, so let's close read 17. It says Tyson is creating a scale. Everyone with me? 581, problem 17. Tyson is creating a scale drawing of the area of his school. The rectangular drawing shows the
Length.
as 20 inches and the width as 19 inches. The drawing uses a
Scale.
of 1 inch to 3 feet. What is the actual of the school in square feet? Now, I want to just go over this really quickly with you because there's an issue when it comes to problems like this, okay? And the problem is people want to try to solve the whole area all in one shot by doing the steps that we did in just one proportion, and it doesn't work like that, okay? So you're finding the area of a school or even of like a bedroom or something like that on a scale drawing. This is how you do it, okay? Step one, all right? Step one is first of all, we need to know, all right? I guess we shouldn't even call this step one. We should call it step star. We need to know that the area, in this case, it's a rectangle, right? They call it a rectangular drawing. The area of a rectangle is length times width. Okay? So, with that said, here's what I'm going to do. I'm going to do the length, and I'm going to figure out the width. Then I'm going to figure out the area. So those are exactly the major 3 steps that we're going to do. So step one, I'm going to go ahead. Let's find out the length of the school grounds. So I'm going to go ahead and do all the same steps that we just did. I'm going to write my scale, which is 1 inch to 3 feet. I'm going to then set up my proportion, inches over feet. And they said on this drawing, the length is 20 inches. So I'm going to put 20 inches. Now this is nice because I could just multiply both top and bottom by 20 to get 60 feet. And the length, ladies and gentlemen, is 60 feet. Now step two, I'm going to figure out the width separately. These are 2 separate problems, like 2 separate smaller parts of the problem, I should say. So I'm going to use the same scale because it's the same drawing, 1 inch to 3 feet. I'm going to put inches over feet as I set up my proportion. And it says in here, the width is 19 inches. So I'm going to put 19 inches. So we multiply both top and bottom by 19. And 3 times 19 would give us 57. So we end up with 57 feet for the width. So ladies and gentlemen, because area is length times width, here's what we're going to do. Area equals the length is 60 times the width, which would be 57. And I can go ahead, grab my calculator. Area is 60 times 57 equals 3,420. What we just did was step 3. In this particular problem, we're finding out our area. Now don't forget step 4, and that is put your correct units on. So it is in feet, but be careful, it's the area, so it is square feet. And there's our final answer. Okay, so it's kind of like almost 3 little problems in one. All right? Okay, guys, if you have questions, do me a favor, write them down. Just looking at the time, we do have one more type of problem to go over. Okay? Which is very important, and that is, take a look at on page 579, okay, problem number 3. 579, problem number 3. Okay, here we go. On page 579, problem number 3, it says find the length of each model. In this case, it's a Ferris wheel. But it then goes on, it says find the scale factor. So we need 2 answers for this. So the very first thing we're going to do is we're actually going to find out the length. Now, to save us some time, okay, I'll put step star here as a little reminder to yourself. Just put, you're going to find out the same way that we've been finding out. You write your scale, you set up your proportion, okay? So find the length of each model. But what I want to focus in on, starting with step 1, is the scale factor. Now, if you remember right, in our vocab, scale factor was the scale placed with the same units, then we drop the units and write it as a ratio. Okay? That's what we're going to do here. So we're going to take the scale. Step 1 is take your scale, which is 0.5 centimeters over 1.5 meters. Step 2 is we're going to make sure that they have the same units. Now, in this case, I can change them either both to centimeters or both to meters. If you like multiplying rather than dividing, change the larger unit, meters would be about that big, change the larger unit to the smaller unit, meaning I'm going to convert it to centimeters. Now remember, this is only converting. I'm not solving anything. Converting it to same units. So I keep my 0.5 centimeters. There are 100 centimeters in 1 meter. So considering that, I would multiply 1.5 times 100, and I would get 150 centimeters. Now this is a little more challenging than the other ones you're going to do for homework, but this is how you would do it. So, and now step 3 is I'm going to put it, it's not quite a unit rate, but you want to make sure it looks kind of like a unit rate, meaning one of them is needing to be 1. So, in this case, I'm going to change 0.5 to 1. So, 0.5 times 2 gives me 1. 150 times 2 gives me 300. And here's what I do. To get my final answer, I drop the units. And this drawing has a 1 to 300 scale factor, which means the real ride, okay, real Ferris wheel is 300 times the size of the model. Okay. All right, that is scale factor.